Welcome back to the McTee channel. You're on YouTube Live. And this class is for those in Form 3 now. Those in Form 3, you are welcome to Form 3. And today, we are going to look at topics that will interest you, topics that will allow you to be able to write the next year's BEC very well. So if you're on this our channel, then follow us because, like we always say, we are here mostly for you, the last year students or end of year students. Good. Now today we are looking at a very nice topic and it's very interesting. We are looking at acids, bases, and what? And salts. We are looking at acids, bases, and salts. Acids, bases, and salts. Now we are going to look at what acids are, what bases are, and what salts are. Very important. Now, under acids, we are going to look at the types of acids we have, the strong and the weak acid. A lot of things we are going to do under that. So, take note. Good. So, let's just get right into it. Now, there are so many substances here on earth. So many substances. If I give you water and I give you an acid, you cannot differentiate them because both of them will be colorless. The same as a base. But how do we know if a substance we have is an acid? Now, the toothpaste you use in the house, the tomato you use in the house, some of them, most of the time can be acidic, can be basic. You get the point I'm making here. But how do we know if this substance contains an acid or this is a base? Now, basically, for acids, anytime you dissolve a substance in water, so I have water and I dissolve a substance in it, and the substance produces hydrogen ions. When it dissolves in water and it produces excess hydrogen ions, then that substance is an acid. Very simple. So an acid is a substance that will dissolve in water to produce hydrogen ions. Very simple definition. Any substance at all that dissolves in water to produce H plus ions or hydrogen ions is referred to as an acid. Keep that in mind. Very simple definition. So we take a substance like HCl, and we dissolve HCl in water, and this will the water will separate them, right? If you listen to the compounds, right? If you don't have, then you have to go and listen to compounds. You know, this will separate, and we'll have H plus and Cl minus. You get the point I'm making? Since we have H plus in this solution, so let's say we have a container and we have water in it, we have H2. Then we pour a substance into it, and that substance was poured into this. After pouring a substance, we could determine H plus or ions in the solution. Once we can get H plus ions, then the substance that was here initially is what? An acid. So what's an acid once again? An acid is a substance that will dissolve in water to produce hydrogen ions. Very, very simple. Now, acid comes with what? Comes in different types. So we have types of acids. And the types of acid is basically the source from which we get the acid. You get the point I'm making here. The source of the acid determines its type. I don't know if you understand what I'm saying. Good. So acids are grouped into two, or we have two types based on the source. Now, acids that are coming naturally, we can find them in the apple, we can find them in fruits, we can find them in anything natural. We refer to such acids as well as organic. So the first one is what? Organic acids. Organic acid. What's an organic acid? An organic acids are acids that occur naturally in plants and animals. If you take the human being, for example, inside your stomach is HCl. Yes, HCl. HCl can be manufactured in the lab, and also it is present in the stomach of what? Of most animals. It helps in digestion. One day we'll look at digestion, you understand it. It helps in digestion. That acid, because it is naturally in the stomach, we refer to it as organic. So organic substances are naturally produced. Good. So define an organic acid. An organic acid, you said they occur what? Naturally. So organic acids, they occur naturally. Organic acids occur naturally in where? We can find them in plants. You can find them in plants and also in what? In animals. So this is where we can find what? We can find organic acids. You get the point? I've got an example that in our stomach is HCl, and that is an animal. In plants, you know that when you take your citrus fruits, when I say citrus fruit, lemon, orange, and those things, they also contain what? They contain acid, and that acid is called ascorbic acid. Now, these guys are also known as non-mineral acids. So another name for organic acid is non-mineral. Non-mineral acids. So if I say define non-mineral acid, these are acids that occur naturally in plants and what? And animals. You get the point I'm making here. All the notes will be uploaded to the site, which is www.McTeeClass.com. You have access to the notes, then you follow the lesson. Very simple. So far we've looked at what an acid is. An acid is a substance that produces H+ ion when dissolved in water. The most basic thing is that it should produce what? The H+ ions when dissolved in water, or when it's dissolved in what? In water. And here we have types based on the source. Those that are coming from natural sources are referred to as what? Organic acid or non-mineral acid. So we'll look at some of the organic acids and their sources, but you have to get the notes so that you look at it. One, we have the ascorbic acid. Ascorbic acid, and that is from what? Green vegetables, citrus, and fresh fruits. Fresh fruits contain what? Acid. Yeah. Then we have the citric acid. Citric acid also comes from what? From oranges, lemon, lime, pineapples. They contain what? This acid. And how do you know they contain acid? If you taste lemon, it has a sour taste. That is a characteristic of acid, or a feature of acid, or a property of acid. If you want to know if a substance is acidic or not, taste it. That can be one way. Get it? But be careful when you are tasting them. So for natural ones, when you taste them, they feel sour. They have that kind of cutting kind of thing taste. Hope you understand what I'm saying. Good. That is for citric acid. Then we have ethanoic acid. Ethanoic acid, we find those ones in vinegar. You can find them in sour palm wine. You can find them in beer. So those who drink beer a lot, they have what? They have ethanoic acid present. Then we have hydrochloric acid, HCl. And hydrochloric acid, HCl, is present in the stomach. All this, we have it in the notes. Then we have lactic acid. Anytime you hear lactic, it means there's some kind of milk. So lactic normally goes with what? With milk. So we have that in breast milk and also what? Sour milk. We can have the lactic acid there. So I'm mentioning the types of acid or type of organic acid we have. Listen, we say we can have what? Ascorbic acid. We can have citric acid. We have hydrochloric acid. We have lactic acid from milk and breast milk and sour milk. Then we have malic acid from apple, banana, beans, peas. All these things contain what? Acids. Then we have methanoic acid. If an ant or a bee has ever stung you, the stings of those things is painful because they introduce into your system the what? The methanoic acid. Then we have palmitic acid from palm oil. We have tannic acid from tea and tartaric acid from what? Grapes. All these are organic acids. You understand what I'm saying? All these are what? Are organic acids. Then the next one we'll look at, now that we know we have organic, of course, obviously, since they are organic, there will be what? Inorganic acids. Like we have natural elements and we have those that were artificial. 118 elements we have, 94 of them natural, the rest are what? Artificial. Good. So inorganic acid, these or they are man-made from what? From organic matter in the laboratory. These are man-made acid, or these are made from inorganic material or matter in the lab. So for inorganic acids, for inorganic acids, these acids are what? Are made in the lab. So they are made where? In the lab. So that's what they don't occur naturally in plants and animals, but they are made in what? In our labs. They are made in our labs. So scientists will take inorganic substance, using inorganic substance. So they are made using inorganic matter or materials. Inorganic matter or materials. So you go to the lab and scientists can produce acids. You get the point I'm making here. They will still produce the H plus ions when dissolved in what? In water. I hope you get the point. So when you're asked to differentiate between organic and inorganic acids occur naturally in plants and animals, but the opposite, which is the inorganic ones, are produced in the what? In labs using inorganic matter. Example is sulfuric acid. Example is what? Is H2SO4. H2SO4. I've already taught how to name this thing. That is tetraoxosulfate 6 acid. You can go and check that video out and learn how to name compounds, right? I've already done that for you. Good. Then we have HNO3, nitric acid. HNO3, that is trioxonitrate 5 what? Acid. That's the systematic name or the IUPAC name. Good. Then we also have phosphoric acid, which is H3PO4. H3PO4, this is phosphoric acid. So we have sulfuric acid, we have nitric acid, we have phosphoric acid, then we also have carbonic acid. Carbonic acid is H2CO3. Yeah, carbonic acid. So these are all acids produced in the what? In the lab. If you're asked to give examples of acid, examples of acid can either be organic or what? Inorganic. So you mention any of what? Of this. But if your question was specific, that mention examples of inorganic acid, then we go with sulfuric acid, H2SO4. We go with nitric acid, HNO3. Then we have H3PO4, phosphoric acid. Then we have carbonic acid from carbonate. I hope you understand what I'm saying here. Good. So these are the what? The properties, the examples of inorganic acids. Now, how do I know if a substance is an acid? I told you earlier on when we were mentioning the types of acid, when we got to the citric acid, where I told you they have sour taste. That is one property or one feature of what? Of acids. So we are going to look at characteristics of what? Of acids or properties of acids. But we'll divide that property into two. We'll look at the physical properties and the chemical properties of what? Of acids. So we'll look at properties of acids. Properties of acids. Properties of acids. And I said 1A, we have the physical property. We have the physical properties. We have physical properties. Then we also have chemical properties. So let's look at some of the physical properties. One is that acids have what? Have sour taste. They taste very well. Sour. Good. So if you want to feel how it tastes, just buy a lemon. You get the point? And buy lemon or lime. Then cut it and taste it. You see what I mean by what? By sour taste. Good. So they have a sour taste. They have a sour taste. 2. They are corrosive when concentrated. When we say corrosive, acids will burn you when it's concentrated. You get the point I'm making? We can dilute it, but when it's concentrated, acids are very, very corrosive. They can corrode things. Good. Then they have a pH, so they are corrosive. They are corrosive when concentrated. They are corrosive when concentrated. Now they have a pH, so their pH is less than 7. Now, why do we use 7? 7 because once your pH is 7, then you are neutral. We'll look at all that. pH simply means the power of hydrogen. Power of hydrogen. That tells you that the more hydrogen I have, the more acidic I am. Listen to what I'm saying. The pH of a solution tells you how acidic, how basic, or how neutral a solution is. And the scale ranges from 0 to 14. So 7 becomes the middle. So anyone less than 7 is an acid. We'll look at pH scale soon. Then anyone greater than 7 is a base. So for acids, they have pH less than what? 7. The power of hydrogen in it is more You get the point I'm making here? Or the hydrogen is missing more. If the hydrogen become less and the OH become more, then the substance become what? Becomes a base. I hope you get the point I'm making here. Yeah, I'll explain all that, but let's take it one after the other. So we look at the first physical property that acids have sour taste. They are corrosive when concentrated. It has a pH less than what? Less than 7. Then acids, they conduct electricity. Good. Acids can also conduct. They conduct electricity. They conduct electricity. Acids can conduct electricity. Then finally, we say what? Acids, they change blue litmus paper red. Red normally means what? Danger. So we call those pH or indicators or acid-base indicators. Now, when we put acid into, or we have a litmus paper, I'll show you a litmus paper. When we have a litmus paper and you put into a substance, and the blue litmus paper changes into red, that means the substance is acid. So we say acid, they will change blue litmus paper. They change blue litmus paper to what? To red. That means if I have, and take note of this, normally in practicals, so they are going to do, they'll give you some statements for you to be able to give them the color changes, or they'll prepare a table for you and give you some substances so that you tell them the color changes. Remember that I said when you put a blue litmus paper into a substance and it changes to red, that means that substance is what? Is an acid. But if I have a red litmus paper and I put it into a solution and it remains the same, the color does not change, it gives me two things. Either the solution is water or an acid. Take note of that. Water is neutral, so it has no effect on pH, on the litmus paper. The color will not change. You get the point I'm making here? Good. So when I put a red litmus paper in a solution and the solution does not change color, or the paper does not change color, then we say that it can either be water or what? Or an acid. Good. So these are some physical properties of what? Of acids. Let's look at some chemical properties of acids as well. Some chemical properties of what? Of acids. Chemical properties of acids. So we said we can have physical properties, and also the B type is the what? Is the chemical properties of what? Of acid. Chemical properties of acids. Are we there? Good. So one is that acids react with bases to produce salt and what? And water. That's one chemical property. When an acid comes into contact with a base, the product is referred to as what? It's called is salt and water, and that reaction is called a neutralization reaction. The thing becomes neutral. I have an acid A, then I add it to a base. When I react these things together, these things are called reactants. We are from three, so we know them. These things are called what? Reactants. The product I will get here, the products are what? Salt and water. Let me just use this to represent them. Salt and what? And water. So when an acid reacts in a base, it produces salt and water, and that reaction is referred to as what? A neutralization reaction. We'll define it soon. So one chemical property is that acids react with bases to produce salt and water. Acid react with bases to produce salt and what? And water. I hope you get the point I'm making here. Good. So that is one chemical property of what? Of an acid. Two, they react with what? With metals to form. If we do metals and the metals, you know this. Acids always react with what? Metals to form salt and hydrogen gas. So they once again react. They react with metals. They react with metals to produce salt and hydrogen gas. To produce a salt and hydrogen gas. I'll show you that reaction soon. So to produce salt and hydrogen gas. Produce hydrogen what? Gas. Good. So I have a metal which is Zn. plus an acid HCl. This is a metal. When acids react with what? Metals. This is a metal because zinc is 2 plus and the positive guys are what? Are metals. So zinc 2 plus this zinc 2 or zinc plus this will give me H2 plus ZnCl 2. This zinc chloride, right? Let me balance the equation. Is the equation balanced? Let's put 2 in front of this and balance the equation. From 3, we should know how to balance equations by now. So we have balanced this equation. A metal reacted with an acid and is giving us hydrogen gas and a salt. I hope you know what this is. This is a salt because we have a metal and a metal combining. We get a salt. I hope you get the point I'm making here. Good. So that's another property of fiber. It's a chemical property. Take note of this. Acid reacts with bases to form salt and water. I said that reaction is called what? A neutralization reaction. So that's neutralization. Then acid will also react with what? With metals to produce salt and hydrogen gas. Now these same acids will react with what? With carbonates. When they react with carbonate, they produce salt, water, and carbon dioxide gas, CO2 gas. So the next one is that the acids react with carbonates. They react with carbonates to produce salt, produce a salt, water, and carbon dioxide gas. So acid react with carbonate. So if I take HCl plus a carbonate ion, which is CaCO3, CaCO3, it's a calcium trioxocarbonate 4. Good. And that will give me this. I said we'll have what? We'll have carbon dioxide gas, a salt, and what? And water. So we have H2O, we have CO2, then our salt will be what? Calcium chloride, CaCl2. Good. When you go and watch the video on how to write these things, I've explained them, you know. If you don't get it, just comment on the section. I'll come and have a very short video on balancing and what? And writing of chemical equations. So let's see if it's balanced here. So for this one to balance, let's add 2 to this. When we add 2 to this, it's balanced. It's balanced. So 2 hydrogen, 2 chlorines, 2 hydrogens, 1 calcium, 1 calcium, 1 carbon, 1 carbon, then 3 oxygens and 3 oxygen. 1 plus 2 gives us 3. So this is the balanced chemical equation. And these are the products. So these are chemical reactions. Take note. Acid is reacting with what? With the following, with the bases. So the easiest way is that acid will react with bases to produce what? Salt and water. When they react with metals, they produce salt and what? And hydrogen gas. Then, so take note of this. The moment you have this hydrogen, this H here tells you that we'll have hydrogen gas. And when the Cl combines with it, we get salt. So that's the easy way of recalling this. Then we also have what? We have this. This one to know we'll get a salt. We'll get what? Hydrogen gas from this. And we also have what? Carbon dioxide from that. So keep that in memory so that it becomes easy for you. How to get the point I'm making here? How do you understand what I'm saying? Good. So that is, and we have an acid HCl plus NaOH, which is also a base. That tells me this, there will be what? There will be a salt, because this and that will combine, and that will give us water. So keep that. When you see them, the non-metal here tells that there will be a salt, and H with that will give us water. So this will give us NaCl, Na2 chlorine, no, NaCl, then plus H2O, H2O. So this becomes the product. I hope you got what I told you. Yeah. So when you want to remember this easily, I said that anytime you have an acid, so an acid, use HCl for easy remembrance of the practical, of the chemical properties. HCl reacts with what? With NaOH, which is a base. The H will produce hydrogen, and that's hydrogen gas, and the chlorine will combine to give us salt. So in either case, we'll have salt and water. So here we have salt and hydrogen gas. Hydrogen gas because there was no O for the hydrogen to form water. That's for you to understand. So there was no O for the hydrogen to form water, so it became hydrogen or gas. But there was a metal that will combine with chlorine, a positive with it, so we'll get a salt. Keep this, and this will help you. Just understand this. Now here, there's Cl, that means there'll be a salt form. there's hydrogen, there's this. That means, listen, this is very easy. This one tells us from here, we say hydrogen, there will be hydrogen with this, that means there will be water because of the presence of the O. Na and Cl tells us that there will be this, there will be salt. Now here we had HCl and Zn, zinc chloride. The Cl alone tells us there will be a salt. Hydrogen, when I look through, I don't see any water. That tells me I'll get hydrogen gas. When I come here, HCl, oh, there's O. That means that the O and the H can produce some water somewhere. Cl is present. That means there'll be a salt somewhere. So you know the product. And the CO3 will tell me that there'll be what? There'll be carbon dioxide. So anything here, carbonate. Once you react with carbonate, there must be carbon dioxide gas. I hope you understand this. The next one is that they react with ammonia to form ammonium salt. Acids react with what? Ammonia. So they react with ammonia to form ammonium salt. Right? Good. So that is for the acids, right? These are the reactions. Good. So these are chemical properties of acids. Let's move on. We are going to strong and weak acids. Acids can be strong and acids can be weak. Now, the strength of an acid depends on the number of hydrogen ions in the solution. If this is an acid and that's an acid, if this container A is an acid and that container B is also an acid, but A produces more of the H plus. So we have, let's say, 20 of the H pluses here, and we have 5 of the H plus. We are just looking at something. Now, that means that because I have produced more of the H plus and you have produced less, I'm a stronger acid than you are. Yeah, we are acids. We've all been able to produce the H plus ions, but I have produced more of the H plus ions and you have produced less of the H plus ions. So more H plus, less H plus. That alone differentiates. Yes, we are acids, but I am a stronger acid than you. I hope you get the point I'm making here. With that, how do we define strong acids? Before we form the H plus, the reaction undergoes something called dissociation. And that's what I demonstrated earlier. When I wrote the HCl, and I gave you this, I said we have this, the earlier on the equation I wrote, we have H plus and Cl minus. This reaction is a dissociation reaction. That means, just for understanding's sake, the water will split these guys into H plus and Cl minus. Let's put it that way. For understanding's sake, the water splits them into what? Into H plus and Cl minus. The more H pluses the water can split, we call that dissociation. It's this one, they've associated. So they came together to form this. The water dissociates them. So you take your plus, I take my minus. We call that dissociation. When that dissociation occurs and you produce more of the H plus, then that means you are what? You are a strong acid, right? So strong acids are acids that will dissolve completely or dissociate completely to produce the hydrogen or ions. Complete. Everything dissolves. There are some acids that will still hold back. Not everything in them dissolves. Those ones become what? Weak acids. You get the point I'm making here. Now, so that is the understanding of strong and weak acids. Strong acids are acids that will dissolve completely. So the term here is that strong acids will dissolve completely and weak acids will dissolve what? Will dissolve partially. Good. So we are looking at strong and weak acids. Weak acids. We said the strength of an acid depends on the number of hydrogen ions you have. You get the point I'm making here. It depends on the number of hydrogen ions you have. Now, for you to get more of the hydrogen ions, so for more hydrogen ions, you need to dissolve, because we can only tell if a substance is acid from the beginning that it should dissolve in water to produce what? The H plus ion. That dissolution, if you dissolve completely, in order to produce the H plus ions, if you dissolve, we said that the strength of an acid depends on what? On the number of what? Of hydrogen plus, right? Take note. Now, more hydrogen plus means that you are what? You are strong. And for you to produce more, you need to dissolve. So this is the term there. If you are defining strong acids, they are acids that will dissolve completely to produce this. But for less H plus, you dissolve what? You dissolve partially, right? So the partial dissolution of a substance to produce it partially means you have not given out everything. So you're not strong. You get the point I'm making? You are doing something. If you give in all, that will tell you how strong you are. You get the point? I'm trying to raise this thing. I'm putting all my effort. That tells me I'm strong. But if you do that partially, people think you are weak. And that is true. You get the point? If you do things partially, it means you are weak. But if you are strong enough, you do them completely. So the term that separates them is what? Is the complete and the partial. So what are strong acids? Strong acids are acids that will dissolve completely to produce the what? The hydrogen ions. You get the point I'm making here? They mostly inorganic. They are mostly what? Inorganic what? Acids. Strong acids are mostly inorganic what? Acids. Organic acids are weak acids if they were strong. That means if you taste lemon or lime, remember when it's concentrated or when it's strong, it becomes what? It becomes corrosive. That means you corrode your intestines once you take in the what? The lemon. But because they are weak acids, you get the point I'm making here. Because they are weak acids, they don't corrode our system. I hope you get the point I'm making here. So that is about strong and what? And weak acids. So I've defined strong acids. So example, so all these things here in one box will give me the strong acid. And all those here will give me what? The weak acid. So what are strong acids? I've defined them. What are weak acids? Weak acids are acids that will dissolve, but what is their solution? They dissolve partially. You get what I'm saying here? They dissolve what? Partially to produce the H class of ions. I hope you understand this. You get the point I'm making here. Good. That's very, very important. So I said examples, we have HCl, we have HNO3, we have H2SO4. These are examples we have all in the notes. Then we have examples of this, the phosphoric acid, PO4, then H2CO3. Now, normally I tell them to find it, that's very easy. When the difference between the hydrogen, number of hydrogens and oxygen gives you 2, that means it's strong. That's a simple thing. When you have something like this, the difference, this is 1 hydrogen, that's 3 oxygen. 3 minus 1 will give us 2. That means that this is a strong acid. When the difference between this and that is 2, that means it's strong. So 4 minus 2 will give us 2, that means a strong acid. But these guys will give us, when we do the subtraction, we get 1, that is 4 minus 3 will give me 1. And 3 minus 2 will give me 1. They are what? Weak acids. Just keep that in memory just for the sake of what? Understanding. You get the point I'm making here. Very simple. Good. Then we come to the dilution of what? Of acids. When we say we are diluting acid, that means we are reducing the concentration of an acid. Let's put it this way. Now, when you buy a sugary juice or fruit juice or anything, and you decide to add water to it, what you are doing is diluting. You are reducing the concentration, but the sugar content is the same. Don't get confused. The sugar content is the same, but you have diluted or you have reduced its what? Concentration. In other words, you have reduced its sweetness. That's all. So when we talk of dilution of acid, it's basically reducing the concentration of an acid by adding the acid to what? To water. Not adding water to the acid like you do with your normal Coke or normal drink. You add water to here. To dilute an acid, we add the acid rather to what? To water. You get the point I'm making here. So dilution of acid is the process. Let's end with dilution of acids. Let's end with dilution of acids. Dilution of acids. So dilution of acid is basically what? The process of adding acid to what? To water to reduce its concentration. The process of adding what? Adding an acid to water to reduce what? Its concentration. Thank you very much for joining the class. When we meet again, we'll still continue from what? From the dilution. Look at the uses of acids. Then we look at what? Bases. But take note that so far we have discussed what an acid is, the types of acid we can have, organic and inorganic. Then we've also discussed the properties of acid, the physical and chemical properties. Take note of the tricks we learned to know what the products will be. Sit back, watch the thing, and try and think through. Put your own things together, and you will get it right. Then we look at the strength of an acid, which depends on the number of what? Of H plus you have. When you dissolve completely, you are a strong acid. When you dissolve partially, you are what? A weak acid. Thank you very much for joining the class, and stay tuned, because from now till you write your paper, they are going to give you more stuff. Stay tuned.